del futuro? Bueno, es un gusto personal para mí el poder presentarles a ustedes una empresa que está transformando y efectivamente cambiando y marcando el paso del futuro. Tenemos el día de hoy con nosotros uno de los cofundadores de la empresa Tesla. ¿Conocen a Tesla? Perfecto. JB Straubel nos va a platicar un poco acerca de la empresa, nos va a platicar un poco acerca del futuro, nos va a platicar un poco acerca de qué es lo que está cambiando y cómo esto va a cambiar la vida de cada uno de nosotros. Demos un fuerte aplauso, por favor, a JB Straubel de Tesla Motors, cofundador y director de tecnología.
Thank you. Good afternoon, everyone. Apologies, I'll present in English today. My Spanish is not very good. But it's great to be here. I'm really looking forward to talking with so many aspiring new entrepreneurs and giving you guys a little bit of a view into the history of Tesla and how we've grown and also some of our mission, why we do the things that we do and what motivates us every day. So I think the important place to start, for us is to think about, what is it in our mission? Sorry, 1 second here. This thing doesn't want to cooperate. But I think the important place to start is to think about, what is it in our mission that sort of, got us going in the first place? And, for us, sorry for the distraction there. For us, it's really important to think about what problems are we solving. And, our time is the most important thing that we have for us. Everybody only has, thank you, a limited amount of time here. So we have to be really careful to make sure that what we're working on are the most important problems and the most relevant things, not just for us, but for, I think, the whole planet. And, the thing that we looked at, before we started the company was the environmental impacts of energy. And to us, that's probably the biggest, problem facing, really all of society in the next, century, is how do we move from a world that burns fossil fuel with all the negative impacts of that. We see huge negative impacts in all the big cities and very congested areas from the local pollution that burning fossil fuel creates. But then there's also diverse impacts. How do we move from that to something that can be sustainable so we can keep doing everything we do, having the prosperity that fossil fuels have given the whole world over the last, 2 centuries, but without the negative impacts. And it's not just local pollution, of course. Probably the most difficult problem that we'll have to solve as a human species is how do we affect and fix the global problem, the global pollution problem of CO2 that burning fossil fuels has created. And this graph, I think, is an interesting, one. You've probably seen many versions of this, but it's, I think, a powerful reminder of just how, far out of the normal we are today. Today, the atmospheric concentration of CO2, even just here in this room, you can measure it everywhere in the world, is now over 400 parts per million. That's roughly double, what the average has been for almost the last million years. So in the last, very short amount of time, we just skyrocketed up and have changed this in such a huge way. And a lot of people think, the Earth's atmosphere is huge. We couldn't possibly screw that up. You go outside and you look at the sky and it's just, it goes on forever. But actually, the atmosphere is really pretty tiny. It's very, very thin, and it's just such a small and fragile extent of the whole world that we actually can change it, and we are changing it much faster than most people think. And if you look even just kind of zooming in the last, few hundred years since we started burning fossil fuel, this is essentially what's happened. Since the Industrial Revolution, we've just launched up on this curve. And fixing this, changing the trend here, is profoundly difficult. This relates to every single thing that we do. Every car that's driving, out there, except for a very few, electric or maybe some hybrid vehicles, plug-in hybrids, all ships, buses, trains, airplanes, cargo movements, all this stuff, electricity generation is creating this upward trend. So to stop this, we have to reinvent, the way that the whole world, converts and uses energy. Which, as an engineer, for me, it's a pretty exciting challenge. We don't get very many, of these kind of fun challenges that come through our lifetimes where we get to, reinvent so much of the infrastructure in society. and start new businesses doing it, have business opportunities and ways to, make money and create also, success and cleaner solutions. And there's kind of a sort of sobering, milestone that we passed just this year, which was that 400 number I mentioned, the atmospheric concentration of CO2 went above 400 permanently, earlier this year. And this is the first time that's ever happened. It's always been, below it or just dipping above it temporarily. But, now it's above it permanently. And basically this will be above it for as long as everyone here is alive. We don't really have any way that we can imagine right now to turn the curve around, stop it, and bring it back below 400 before everybody in this room, has gone on to the future. So, that's kind of sobering to me, that we've done something to the atmosphere that's going to affect us for the rest of our lives. There aren't many things with that much inertia that we do. Usually we think, if we make a mess, we can just clean it up, next month, next year, we have plenty of time. But this has so much inertia that it crosses over, human, lifetimes and generations. And the impact of this also is, of course, on temperature. And this is a cool way, I think, to visualize that. This is an interesting graph that a climate scientist in the US put together that shows the evolution of the world's temperature from the early Industrial Revolution through the middle of this century and continuing on toward today. And you can see it continue to spiral out. And what's so telling to me is just how much it's accelerating in the last few decades. It's really striking, and I think, a little bit startling. This is just a similar way to view that graph all in one place. And 2016 has continued throughout this past summer, setting world records every single month. Hottest month in June, hottest month in July, hottest month in August. And, it's not just a little bit hotter than all of those other lines. It's sort of meaningfully off the entire graph. So, when we combine all this is what brought us to focusing at Tesla on how do we accelerate sustainable energy, how do we accelerate sustainable transportation. These were the really meaty, big problems that as entrepreneurs, we felt, this was worth our time. This is, going to be a trend that'll be with us for decades. It's not just going to be a quick fad, that might last for a few years and then be done. This is something we could dedicate our careers to. So that's what we set out to do when we started the company about 13 years ago now. And, it took, I think as many of you guys, maybe as entrepreneurs realize, it takes a lot of, courage, to go out and sort of fight what, might be seen as the trend or the sort of established, norms. And Tesla often gets labeled as, today we're this disruptive company. We're disrupting the auto industry. We're disrupting the energy industry. But, often disruption ends up getting this really negative connotation. If you look around for what does the word disruption mean, usually that's seen as something you don't want to do. We even start teaching our kids at pretty early ages that, they should, stay orderly. They shouldn't, create big chaos or mess, and they shouldn't be disruptive. And in addition, we always are kind of teaching our kids and teaching society in general that we should follow rules and, make sure we, follow all the different things that, businesses say we should do or governments say we should do. But I think it takes a somewhat of a healthy, maybe a healthy but, respectable disregard for some rules to be a good entrepreneur. You've got to challenge, what are the existing rules and say, are those relevant? Do they make sense? Should I even really be following that same rule anymore, or were the reasons it was put in place obsolete? And in big companies especially, I think they tend to accumulate rules over many, many years, that are based on mistakes they made or technologies that didn't work. And all of those rules tend to constrain what people can do in the future. So this is, I think, one of the coolest things about startups is that, you can basically start with a clean sheet of paper. You don't have a rule book that constrains you on what you cannot do. And that gives, people that are starting new companies a fundamental leg up over even the very biggest companies. In a way, it's the bigger the difference between small and large, the bigger the benefit that you have. Because you can do things that they would never let themselves do, take risks that they would never do. And for Tesla, when we were, getting started, one of the things we jumped into was going into a vehicle category that was completely different than anyone expected was possible. We started building an electric sports car. And this was at a time when basically every other electric car was essentially a golf cart, maybe a neighborhood electric vehicle that could go 30 miles an hour or something like that. And that's what people thought electric vehicles could do. Even I would tell my friends when I was getting started in the company, I was really excited and wanted to show off what we were doing. They all thought we were building a big electric golf cart. So it was kind of frustrating, to be all excited about this and then have your friends think that you're building something that, goes in the neighborhood or goes off on the little golf course. But, this was key to changing perceptions. We had to reinvent what electric cars were known for, and we had to convince all of the investors, even early customers, that this technology was something very different than what their stereotype was. And it was back in about 2005 when we were first building our early prototypes. This is not that long ago. It's just a little over 10 years ago. So it kind of gives you a sense of how fast that perception has changed. In 2005, there was basically no concept of electric cars. People didn't know what this was. And there was a huge change that happened, enabling us to get started. And it was an advancement in battery technology. Lithium-ion batteries, which today everyone has heard about. It's common. Probably everyone's carrying one or more of them in your phone or your laptop computer or other devices. These really didn't exist, in the mid-90s. They weren't commercialized yet. And the auto industry, the last really serious attempt they gave to building an electric car was kind of in the late 90s, before Tesla started. And GM tried to build this car they called the EV1. It was a great, really a great vehicle. They did an excellent job engineering it, but the battery was not very good. And they could never get very much more than 100 miles of range, which just wasn't enough. Customers didn't see that as usable. They couldn't convert from a gasoline car, and when you put them side by side, it just wouldn't compete. So GM kind of gave up on this. The whole rest of the auto industry more or less gave up on this for almost 10 years. And when Tesla came in as a tiny startup and looked at this in kind of the early 2000s, we said, why can't we use consumer electronics battery technology? Why can't we take the same laptop battery and the cell phone battery that had sort of just been invented and then try and put those in a better electric car? And, that's more or less exactly what we did with the Roadster. Everyone we talked to thought this was completely a crazy idea. Lithium-ion batteries in those days were better known for exploding and catching fire. And of course, now with Samsung and others, people are kind of thinking about that again. But, this was a time when no one had put them in a car yet. So stringing together thousands of them, building a whole car out of this was kind of seen as a crazy idea. Every investor we talked to, more or less told us we were nuts. No one would give us money in the early days. And, we had to be really persistent. The only way that we were able to get started was actually by, working with, individuals that were willing to take huge risk and who really believed in the environmental benefits and believed in the technology, even though on the surface it made no sense. Starting a car company in Silicon Valley in California, building it with these batteries that, people were worried would explode. So this is kind of what we started into with the Roadster. It was not an obvious proposition. But we did make it work, and we got the Roadster delivered. We ended up shipping a few thousand of those cars, which by today's standards is pretty tiny. But for new electric vehicles, it was a first. And we were able to actually get a fleet of cars on the road all over the world and start learning. And what we learned from the Roadster was key. We learned people's habits. We learned how they actually used a full-function electric car. What did they do when they had 200 or 250 miles of range? And when would they charge? How long did they prefer to drive? All these different things that, we just had to guess at when we built our very first product. We started to gain data. And this data, was in the form of just miles and accumulated miles in the fleet of cars. We had computers in every car that could record some of this data and then send it back to Tesla so we could, learn even as the customers were using them. And we used all that to go to our next product. So the Roadster was something, really at the bleeding edge. We sort of barely put it together with a small group of people. But from that, we jumped to what is our next product we call the Model S. And most people may have seen that product. That's probably what you think of when you imagine Tesla, as you think of the Model S. But when we started it, it was a clean sheet of paper. And I think this is a really great example of sort of not having a rule book, because we only had a few hundred engineers at the time, and we had never built a car before. We had no idea how to do this, honestly. We didn't have that many people that really had worked in the car industry in the past. And we more or less just had to apply good engineering first principles from the ground up and design this car. And the whole car industry, again, told us, we can't do that. We didn't understand it. They were kind of patronizing and saying, we don't know what we're doing, and, they've done this for 100 years, so how could a small company ever actually take this on? And I'm sure any entrepreneur, jumping into a new field, especially an established new field, will end up hearing the same exact comments, from all of the incumbents. So you just have to, kind of make sure you don't listen to those a little bit, and sometimes, ignore the criticism and focus on, what you think is right and where you're confident there's demand and there's a market. And with the Model S, starting from scratch gave us some really key benefits also. We were able to put the battery pack in the bottom of the car. We didn't have to work around where a gasoline engine used to have been. We could put the battery at the lowest point in the car. It still is quite heavy, so having it very low to the ground gives the car great handling with a low center of gravity, so it can corner, it can brake and accelerate much more easily. And we also were able to redesign, the interior and some of the other components. In the end, the Model S ended up being, I think, one of the best vehicles of its generation. We've ended up, outselling most of the competing luxury sedans, which is something none of the car companies were expecting. We ended up winning a bunch of car, awards, things that were coming mainly from, very conservative, research groups who would drive the car and just fall in love with it. And I think the key thing is that the new technology, gave us this leg up. Even though the car companies, had vastly superior, budgets, they had way more money, they had more people, and they had more experience, frankly, developing cars, 100 years of experience. Because this was a new technology pathway, they didn't have much experience there. And we had these fundamental benefits that we could have performance and efficiency together. We didn't have to sacrifice, one for the other. You can have a car that ends up being the quickest accelerating car in the world, but it also has over 100 miles per gallon equivalent. That was crazy. You can't do that with gasoline. You can't sort of just keep making gasoline more and more efficient and still have high performance. They kind of trade off against each other. So with electric, we could break that trade-off and we could go straight to having both. We also ended up being able to improve our range to a point where today, electric vehicles can get over 300 miles of range, which is, again, unheard of when we were starting out a few years ago, when people were thinking maybe 100 miles would be the best we could do. Today, well over 300 miles. We also have an SUV we call the Model X, built on that same platform. This car, is kind of surprising people with what it can do in towing. It turns out electric motors, are so much better at creating torque than gasoline engines, that you can do all these, great things. From a user point of view, the accelerator pedal is just instantaneously controlling torque. If anyone's ever driven like a remote control electric car, and seen how crazy the performance of those things are, you kind of get a sense of what can happen when you scale it up. And all those same, benefits are still there even as you scale it up. And not just on the propulsion side, but another area where we kind of threw away the rule book designing a new vehicle was in the entire infotainment system. The way that the user in the car interfaces with all the data, with all the systems, and thinking about, how do I control that? And the typical way of doing this is, you have a lot of knobs and buttons. Everything is kind of, laid out with a bunch of different, physical objects that you push and turn. But, we looked around in the world and said, none of the modern electronic interfaces, have that many buttons. Everything was moving toward, touch displays or flat panel displays. And we said, well, why can't that happen in a car? Even airplanes, modern airplanes have, a bunch of, basically, flat panel displays in the airplane. They're not full of knobs and buttons and gauges anymore. So, we decided to do this in the car for the first time. And it was pretty risky. Most people were telling us that using touch in a car, that's pretty scary. What if people don't even like it? What if they're bouncing around and they can't even touch the right thing? So, we kind of threw all that criticism away and just said, we're going to try it. We're going to jump in. We think it's right. And we essentially built a gigantic iPad in the center of the car. All of the information in the car is, on this flat panel display. All the controls, the stereo, the climate controls, and everything is software controlled. So another huge benefit that we didn't even totally understand in the beginning was how this would let us continue to upgrade things. Over time, we can improve the software And we can send it wirelessly over the air to the fleet of cars and update the look and feel or even the functions and performance of not just the user interface, but actually even the controllers elsewhere in the car. So for the first time, we could make a vehicle that was actually over-the-air upgradable for its entire life. And we're pretty familiar with this with our phones today, how often we constantly are getting software updates for your phone or for different apps, things like that. But a car is no different. There's no reason that a car shouldn't have the same series of regular software updates that keep making it better and better, giving it new features, keeping it current with new technologies that come out or new features. And all of this is kind of new to the industry. No one had done this. It was sort of amazing to us, but it seemed like common sense. And eventually, all cars are going to have this. It's inevitable. So this is kind of a cool thing that we were able to do as a startup because we didn't have a rule book and we didn't have all of these corporate risk rules that we could not take. We could follow our gut instinct here and just go in a direction that we felt was right. And today, if you look at the Model S fleet and how much data we're collecting with that fleet, it's pretty interesting. This is actually the same graph as the one we saw before. That little green line at the bottom is the roadster data. And it gives you a sense of how much this market is growing. We now have hundreds and hundreds of times more data, billions of miles of driving that we can learn from and understand what people actually do with their cars and how they work. And it's starting to make a meaningful dent in how much fossil fuels people are consuming. When we can start to convert billions of miles from gasoline to electric, that starts to move the needle. And one way that we've also been able to do this is by focusing a bit on infrastructure. More than, again, many of the existing industry participants focus on infrastructure. To us, we realize that an electric vehicle is a lot like an electronic device for people. And if you buy a really great phone, even if the phone is amazing, if it has a terrible network, it's not very useful to you. And you don't really like it very much. You tend to not use it. And it turns out that electric vehicles have a lot of commonality with that. If you buy an electric vehicle and you can't find places to charge it, if you can't drive it, all the places you want to go and find convenient charging there, it really limits the overall value of that product to you. And it limits the markets where we could sell them. So to us, solving the network problem in a way that was convenient for the user was part and parcel to the product. They really were kind of one and the same thing. Most of the existing industry thinks of the network problem as just someone else's problem. They've never had to worry about gas stations. That must be some kind of energy infrastructure problem. The government should fix it, or maybe some big oil companies should fix it. But it certainly has been very fragmented so that car companies don't get involved in oil infrastructure. But with Tesla, we felt this was critical. So we jumped in and we started developing our own infrastructure, our own what we call supercharger stations, where the cars could recharge very, very quickly in about 30 to 40 minutes, recharging most of a full tank of gas. And this would let people drive for 3 or 4 hours, stop and charge for 30 minutes, and then keep driving for another 3 or 4 hours. And we started building out this network all around the world. This is what it looks like in the US today. And to me, it starts to look a little bit like a map of a cell phone network. People look at this and they kind of think about, well, where do I want to drive? I guess I might go there, I might go here. And then they, decide if that vehicle is a good fit for them. And we're also doing this in Europe and in Asia. We've started building this network out, all the way from the south of France, up to above the Arctic Circle in Norway. And today, this is a huge benefit, that we've been able to discover, for commercializing electric cars. And even more important than for the Model S, this is really critical as we continue to reduce the price of the vehicles. Because, our mission is not just to make, expensive, high-performance cars. A lot of people think the Tesla brand, must equal, very high luxury and very high cost. But, to achieve our mission, to really make a change in energy across transportation, we have to build a lot of cars. And today, the biggest barrier to selling even more cars than we do is the cost. They're just too expensive. So most of our internal work is on how do we reduce the cost of the core components and make them more and more affordable and more usable. And having a great network of charging everywhere in the world, is one key benefit that lets people adopt, these cars more easily. So for us, we spend a lot of our time working on our next generation, lower cost car. We call it the Model 3. This is about a $35,000 car, US dollar car, that can go about 215 miles. And this is about half the cost of the Model S. So it's a huge improvement in cost in one product generation. A lot of people wonder, when are we going to get, below $20,000 or, even $15,000? But if you look at the improvement curve and how fast, this technology is coming down in cost with each product generation, it's pretty incredible. The Roadster, was well over 100,000 US dollars. Then we cut that almost in half for the Model S to go to 75,000 US dollars. And now the Model 3, which we're going to start shipping next year, down to 35,000 US dollars. So we don't see this trend stopping. The technology is continuing to improve. And we launched this car earlier this year, and the demand was immense. We had almost 400,000 orders for this Model 3 in just the first week. So essentially, it sold us out, for several years of production. So I think it really drives home the point that consumers want this technology. Many companies or governments kind of worry that, do they really want something different? It's too hard to use. It's kind of scary new technology. Maybe we should just keep selling and building the same thing. But in fact, we can really see that customers want this. And this really set records for how fast it got adopted and how many people came and put in reservations. And in the U.S. and around the world, in fact, we saw people waiting in line at stores, for hours just to put in a reservation for this car. We didn't expect this at all. We had maybe one or two people working in these stores with a little, iPad taking a credit card reservation, and they were totally overwhelmed. So this was kind of profound that there was this much excitement, for a new technology that people still couldn't even get for over another year. And I think it bodes really well for the future of electric cars and sustainable technology in general. But the biggest problem this is creating for us is how do we actually make that many cars? Getting the orders is great. Any startup can go and get orders for a technology, but to actually build it, deliver it, make the customers happy, that's hard. And with electric vehicles, it turns out one of the hardest parts of scaling them up are building enough batteries. We have enough tires, we have enough windows and glass and wheels and all these other things, but batteries are really new to the world. And still today, right now, the majority of lithium-ion batteries in the whole world get consumed by consumer electronics devices. Something like 75% of all the batteries that are made go into those type of devices, phones, computers, Fitbits, whatever it might be. And, cars and energy uses are not even the majority yet. But with the Model 3, in the next 1 to 2 years, we're going to see that change. And for the first time, automotive and energy applications will start consuming the majority of lithium-ion batteries. And at Tesla, what we're doing is building our own factory to build these batteries. We decided that we didn't want to rely on all these other companies throughout Asia to build these batteries and then send them to us. This was too strategic. So we built our own factory in Reno, Nevada. It's in the western part of the U.S. We've been building this for a few years now, and this is sort of what some of the construction pictures have looked like. But it's a huge undertaking. This is going to be the biggest building in the world when it's completed. The sense of scale is really hard to imagine. And this is going to, in a single factory, double the worldwide output of how many lithium-ion batteries are made. This is what we need to do just in order to meet the demand of Model 3 and also of some of our new energy storage products we're launching. This is just one manufacturer selling one product. And when you think about, this seems like huge scale and it's massive, but this is still just barely making a dent in the overall automotive market. There's something like 100 million new vehicles sold all around the world. Many of them low cost, but 100 million is a gigantic number. So even with Model 3, if we were building 500,000 cars a year, filling up this entire factory, that's 0.5% market share. That's not a lot of market share. That's not anywhere near saturating a market. It's just barely getting started. And most technologies, don't really mature in their cost and their performance, until you're perhaps in the tens of percent or even more of market share. So it gives you a sense of how early on electric vehicles still are in their maturity phase and in their cost reduction phase. And if we can compete as effectively as we are today on performance and price and all these other attributes, it's pretty incredible, what the future is going to hold in just 1 or 2 more product generations, as the costs cut in half again, as the energy density improves, as the range improves. So we think this is going to snowball and grow and get adopted more quickly than most people expect, not just from Tesla, but from many other car makers as well. And it's key that the technology in these batteries is not standing still. Many people think, when is the big battery revolution coming? What's going to happen? But in fact, these batteries are steadily improving every single year, maybe around 5% improvement in their energy density, their ability to store energy in a given amount of mass. That's probably one of the key metrics we worry about. And when we went from the Roadster to Model S, they've improved by about 40%. And when we're designing Model 3, they're about another 30% better. And that improvement just continues on every single year in the background. It's not something where, one day there's a gigantic invention and, the battery is 10 times better. Unfortunately, it doesn't really work that way. A lot of people, hope and wish it would, but the real world, ends up being a lot of small improvements that take a few years to get commercialized, but they're real and they do get commercialized, and they add up over time to really significant gains that can continue to move the needle and make these products more and more affordable. And one of the not very intuitive, maybe not common sense pieces of this is that as you increase the energy density of the battery, you're also reducing the cost. Because in really high volume, things tend to cost about the same as they weigh. You can essentially look at the raw materials that go into the battery and how much those weigh, and that tends to be, what defines the cost. So if we want to reduce the cost, the best way to do that is to use fewer materials. And if you do that, you've just increased energy density. So that's really a key feedback loop that is very helpful that is happening. In addition, we're seeing just raw economy of scale, doubling the industry production volume, smoothing out the supply chain. These things, tend to just reduce the cost naturally, as you reduce inefficiencies in supply chain. And we're, again, just beginning on this trajectory. Today, Tesla and electric vehicles are, maybe a few tenths of a % of overall vehicle market. Very, very small. So the economy of scale that's going to happen as that moves into the single digits, into the tens of %, there's a lot of room to happen still to reduce cost. And we've seen something like this happen in the past several decades with solar, photovoltaic solar power. That's a technology that I'd say is maybe 5 to 7 years ahead of batteries, lithium-ion batteries, in its commercialization. And the cost decline of photovoltaics has surprised almost everyone in the industry. Many people that watch this were just completely astounded, that it could decline this quickly. And today, we see photovoltaic prices that are well under $1 per watt of generation. And this is making photovoltaics, quite widely competitive in places people never expected, generating power, in many places in the world, cheaper than utility power on people's roofs and even at large scale. And these two innovations and advances are somewhat linked for us also. Because again, if you remember our mission is to make sustainable transportation. And electric vehicles are a piece of that puzzle, but in and of themselves, they can't do all of it. We still have to worry about where does the electricity come from that charges the car. It still has to get energy. It doesn't have free energy coming from the battery. So if you're burning coal, for instance, to make the electricity that charges your electric car, you've still done a little bit of a benefit. You've still ended up cleaning up things somewhat over just a gasoline car. There's no emissions at the car itself, so the cities tend to be cleaner. But from a CO2 point of view, you haven't moved the needle as much as you could. And really the best way to do this is to couple sustainable electricity generation with electric cars. And in my view, probably the most feasible is to couple solar electricity generation to the electric car. So this is something that we're starting to work on much more aggressively at Tesla, and we see it as a core part of our whole mission. How do we make the cars cleaner? How do we make the energy that powers them cleaner? And we've launched, last year, a couple of products that we're aiming to do this with. And these are basically adopting all of this engineering and development work that we did for the vehicle battery into batteries that can store energy for the utility grid. So there's two different products, one that can store energy in people's homes, and then also one that can store energy at businesses or factories or for utilities at a very large scale. And this home battery is something we're installing in pretty high volumes now in places in the world like Germany and Australia and Hawaii, where they already have a lot of solar power, but they're getting to the limits on how much more solar they can add. Because without adding storage, there's a fundamental, basically a cap on how much intermittent solar power you can add into the grid. This is just a picture of one of those batteries installed at a family's house in Australia, where they can basically absorb and use all of the solar power that they generate. And for us, we see this as kind of a holistic picture for customers. Today, if someone comes into one of our stores or even any other vehicle maker's stores and wants to buy an electric car, they can only buy one piece. You can never buy solar or you can never buy storage, from the same company. So what we'd like to do is combine all that and have a really simple, no friction way so that customers can come in and, make their whole lifestyle sustainable at their house, basically with one stop, and make it easy to install so that they can essentially have one contractor, one construction person come and put in all these different pieces. They can have solar on their roof, an electric vehicle in their garage, install the charging systems for the car, maybe storage for their house so they have backup power. And it's very feasible to do all this together. So to us, this is kind of a next step in the future of making people's entire lifestyle and their whole home very sustainable. And this kind of does some interesting things, too, from a technology point of view, because for the first time, once people have solar and storage and a car in their garage, and all of it being controllable, you gain a whole new control over the energy flows in that house. Most of the grid today is one directional. It flows from really big power plants, burning fossil fuels, through big wires, down to cities, down to houses. It's one directional, top to bottom. And it was never engineered to do much other than that. But for the first time, with these new distributed energy technologies, you can start to have the grid go in both directions. And you can start to control and store energy at the bottom of the grid, and actually then use the bottom to the top to start to manage demand and to manage the flow and the overall performance of that network. So this is really kind of common sense stuff for people thinking about computers and about computer networks. But in the energy world, it's kind of scary and brand new. So it's interesting kind of watching how this evolves. But as we start to add more and more houses that have these different technologies, you can aggregate them together. You can use the communication links to essentially control all those different houses and all those different cars as if they were one big installation. This is easy to do today. It's not hard stuff from a computing point of view, but it's kind of amazing how you get to a sense of scale where you can do this across a whole city, adding in cars, adding in batteries, and you can have a really meaningful effect on the overall energy balance in that entire city. This is exciting stuff, I think, that's going to end up changing the way the whole grid operates in the future. And there's so many opportunities in this space, for new companies to, be a part of this ecosystem, whether it's in the communications or in the selling energy or installing things. It's a really new area that I think is going to grow a ton. And, one example that I teach actually in a class at Stanford that I think is a fun example is to think about, an island. And when you have an island, you're really forced to solve all of your own energy problems. You can't easily rely on, importing energy across a border because, everything has to come in on a ship. So, Kauai in Hawaii is a great example. It's, a really beautiful island. It has around 65,000 people, and they have a very aggressive goal to try and, make half of their energy consumption sustainable by 2023. Eventually they want all of it to be sustainable by around 2030. And to do this, they're looking at these really low cost of solar power. It's very, intriguing. It's very tempting when you see these announcements and see, wow, solar power is below 4 cents per kilowatt hour, installed in the deserts in Nevada or in the sort of desert areas in the U.S. at huge scale. So they look at this and they compare that to burning petroleum and, in a diesel generator, on the island somewhere, and that might cost 30 or 40 cents per kilowatt hour. But the big challenge here is the intermittency. It would be an easy solution to just offset petroleum with solar if solar, was steady all day long, the way a generator output is. But in fact, solar is really lumpy. You only generate solar during a few hours of the day. So it's hard to rely on that to power something like an island. So if you're the engineer that's trying to invent, the sustainable energy solution for this whole island, and you kind of look at your generator and it runs like this, you've got to find some way to store it. And in reality, this is sort of the perfect example. If there were no clouds or anything else, in the real world, it ends up looking more like that. When there's clouds that blow over and one day is not the same as the next, and you kind of have to deal with, all of this natural intermittency that happens. So looking at that, it gets even harder to rely on just pure solar to do everything you'd want to do. And this is, becoming very real in this island of Kauai. This is a real example. It's not just, make-believe. This is what their demand curve looks like. If you measure, how much electric load there is on this whole island, and what's happening, you can kind of see it very visually in this small grid, is that they keep adding more and more solar, but every year as they add more solar, their demand kind of gets more and more volatile and starts to collapse in the middle of the day. And this all looks fine and good, but as you keep adding this, more and more of it, you end up at a place where you essentially can go below zero. You can only add so much solar to a house or this whole island example before you have to start finding a way to store the energy, or else you don't have anywhere else to put it. So this is where some very large installations of storage are starting to have an impact. And this is a real project that's under construction in Hawaii today that's storing energy at a utility scale. Basically taking the output from a whole field of solar energy, photovoltaics, and then feeding that into a very big battery, and then releasing it back at night so that the island can use the energy when the sun is not out. So this is a really exciting example to me, because all of this technology, the storage, the solar, all of it ends up happening at a cost that's below what they would have to buy diesel electricity for. So to them, it was an obvious decision. They could look at their diesel cost, they could look at their solar cost from a system like this, and immediately start shifting all of their generation away from fossil fuels. And admittedly, this is happening today at a relatively small example in the world, but there are a lot of places in the world that import fossil fuels to burn to make electricity. And today, essentially all of those places have a cost structure that makes it more compelling to install solar and storage than keep burning fossil fuels. And that price curve is just going to keep coming down, because the cost of those batteries will drop, just as it will for the cost of the vehicle batteries, and the cost of solar is continuing to drop. Meanwhile, the cost of fossil fuel, along with its environmental impacts, is continuing to go up. So, from a long-range point of view, we can look at two curves that are clearly on a crossing trajectory. And they're starting to cross in these areas of the world where they have very expensive energy and expensive electricity, but that's going to happen everywhere over time. Eventually, this will be the same way that we generate electricity on the mainland, in major countries that are having dwindling oil resources, or where oil is getting more and more expensive. And we'll fundamentally move from a grid that looks like the one on the left, where the solar is just a little small part of it, to a grid like the one on the right, where solar energy will make up the majority of all the energy, but will need to be stored in the middle of the day. And it's also cool because there's a lot of people in the world today that actually don't have any access to electricity, over 1 billion people. And there's around 1 billion more that have access, but it's pretty unreliable electricity, or it doesn't have sufficient power to do everything they might want. And there's a clear chance, for all of these different people to leapfrog over, the existing structure of the grid. So today, in places like, rural India or Central Africa, they're not going to build out giant fossil fuel plants and then build huge wires, to move them down to the cities. It'll be done in a much more distributed way. And again, an analogy with a cell phone is what's happened between landlines and cell phones. No one today that does not have landlines wants them. We're not going to build out landlines anywhere else in the world. Everyone just buys cell phones. We build an infrastructure of base stations, and people can have a better service with better functionality than they ever would have had from landlines. And I think the same is going to be true, or seen to be true, from energy in the future, where we'll just leapfrog building out a very top-down fossil fuel network, and we'll start to install a very distributed, very robust, and ultimately lower cost energy system in all these parts of the world. And again, maybe bringing it back to the beginning of what I was started talking about. For us, this isn't about how do we get to, some slight reduction in fossil fuel. We really need to not burn fossil fuel. And I think, it's sort of surprising to me, but, I look at all these different targets that we come up with and milestones of reducing emissions back to, 10 or 20 years ago. And, it's all just a very small stepping stone. It's kind of like if we found ourselves in a hole and you're digging, you're in the hole and you're digging it deeper and deeper, and you realize you're actually stuck in the hole and you can't get out. What is your response? Should I dig a little bit more slowly? Because, it's kind of hard to stop digging, so I'll just dig more slowly, even though I'm stuck in the hole. Or should you just say, wow, this is a problem, I'm going to stop digging, and then start figuring out how to get out of the hole? And all of our different, agreements around the world today essentially are digging more slowly. So this is crazy to me. We need to start architecting solutions that actually, allow us to survive and thrive that don't use any fossil fuel. And luckily, we can do that. There is enough solar energy hitting the planet that we can easily do this. It just takes, I think, the sort of will to focus on things, or the courage to focus on things that actually go all the way to not using fossil fuels at all. And, this curve is really, as I mentioned at the beginning, it's incredibly difficult. Imagine what we have to do to make that, completely stop rising and go back to what it was, not in 1980 or 1970, but what it was in 1780 or 1790. That's before we were really burning fossil fuels en masse. So that's where we really need to get to. And overall, to wrap up here, I think we're going to see this happen more quickly than people expect. It's not going to happen because of fear of running out of fossil fuels. I don't think it's even going to happen mainly because of fear of the environmental implications. I think this will actually happen being driven by more entrepreneurial people, new companies, new ideas, startups who are coming up with products that are actually just better than the fossil fuel competition. And, as that starts to happen, consumers, rush to these new products, and they do it because they love the products. They don't do it because they're regulated to do so or they're forced to do so. And that's when you really see adoption happening. When people want to do something because it's just better, that's when we see this accelerating incredibly fast. So, that's what I hope all of you guys can start to think about. And I hope some of you are working in fields that are helping solve these problems or going after these opportunities. There's a lot of really interesting stuff to do. And with that, I'll wrap up and leave a little bit of time for some questions from all of you. So thanks for your time.
Sí. Vamos a llevar a cabo la sesión de preguntas y respuestas. Vamos a hacer una por bloque. Tenemos 5 bloques de sillas, así que levanten la mano para que les acerquen el micrófono. Y empezamos con el bloque de la derecha de...
Maybe we'll just take a couple of questions from each segment and go around. So thank you, sir.
What about public transportation? You are not thinking about doing something around that?
Yeah, public transportation, what about that was the question. And I think it's fabulous. I think we need as much of it as we can possibly get. I think especially where public transportation is done, in clean ways, like with, electric trains or things like that, it's a fabulous solution. I would encourage it, as much as we possibly can. But, we just see a lot of places in the world where, there's a lot of resistance to being forced into using public transportation. And, in some places, it's, I think, a very difficult problem if you just want to say you can't have a car, so therefore you have to ride the bus or the train. And, from the point of view of making products that people really want to use and love, and, that's where we, tried to attack this from making cars that people really want. So even if they do drive their car, it ends up, still being as clean or cleaner than public transportation. Of course, traffic and roads and things like that, it's a different problem that has to get fixed. But ultimately, I think there may be ways to fix that with autonomous vehicles or better use of grouping cars together, things like that.
Right over here.
Yeah. Okay.
You were talking about how we rely on lithium-ion batteries in this technology. So my question is there actually enough material, talking about batteries, in the whole world to replace fossil fuels?
It's a great question, and an important one. Anytime you're thinking about scaling something up, Lithium-ion batteries, do use a fair bit of lithium, but what people don't usually know is they use a lot more nickel and graphite. So the lithium is actually a relatively small percentage of the overall cost and weight of a lithium-ion battery. And at Tesla, we've looked really carefully at this because if we were to have a shortage, it would hurt us the very first. We'd have a big problem. So, we're looking at, visiting mines, working with companies that run these different, refining and purification operations to make sure there really is enough. And it turns out there's a lot of lithium in the world. It's one of the more prevalent elements in the Earth's crust, actually, but it's not very mature. There wasn't much of a market for it. There still isn't much of a market. So the prices are kind of volatile, and it's subject to more speculation. But there is a lot of actual resource in the ground, more than enough. And the other really cool thing with batteries is that none of the material is consumed. So I've seen people often comparing lithium to petroleum, but it's very different. With petroleum, we pump it out of the ground and then we burn it, we chemically convert it, and it goes away into the atmosphere. With lithium, we'll refine it, we'll put it in a battery, but it's all still there at the end of the vehicle's life. We don't burn any of the lithium, you don't lose it outside the car. So what you can do is recycle the battery at the end of life, and you get back all of the materials that you had to put in when you make it. So from an environmental point of view and from a materials sustainability point of view, that's really compelling. So there's really no way that you easily run out of it as long as you have enough to build a fleet of cars in the first place. Once the fleet is built, you can just keep reprocessing it again and again. Maybe one more question from over here now.
Here.
Okay.
Hey there. I don't want to be rude.
Sorry, I think the gentleman with the microphone.
Okay. Sorry. I don't want to be rude or something like that. I just want to know that, I know Tesla Model S owners have had some car accidents using this autopilot, and I'd like to know if this autopilot is completely reliable, more than, I don't know, BMW autopilot or Google self-driving or this Mercedes-Benz autopilot. I think they got one too. So I just want to know if your autopilot is really reliable in this country because of the traffic and those things.
No, thank you for the question. It's a good question. Maybe the thing I would start out with is just, reminding people, how bad human drivers are. I think, most people imagine themselves to be a really good driver, and they just think everybody else must be the bad driver. That's the common perception. But driving your own vehicle, in traffic, on highways and in sort of crazy environments is just about the most dangerous thing that we actually do. It's hundreds of times more dangerous per mile than flying on a commercial airplane or than being in a train or than being in any type of other transportation. So, what we see is a massive opportunity with adding more autonomous and intelligent safety features, to back up and to augment and to make, the human driving experience safer. And, that is really where we're coming from, with our excitement and our, I think our urgency around autopilot. And we've looked at all the data very, very closely, and we are constantly, checking to make sure that we are, in fact, making things safer, meaningfully safer across the fleet and for each driver. So, is it reliable? We think absolutely yes, if it's used in the appropriate way. The technology is still not yet at a place where the human driver can not be attentive or go to sleep or sort of, sit in the back of the car or do their email. That they cannot do yet. So I think the most important thing is for people to, really understand, how to use the systems and use the technology in a way that augments their own safety. And they can really do this if they, basically, still remain attentive, but, engage the systems in the appropriate way. It absolutely is saving lives, and it's making driving safer. Maybe one more here. I'm not sure where the microphone is.
I have a question.
Okay. It's there.
According to Forbes, Tesla is the most innovative company in the world. What's the secret of Tesla to achieve it?
The secret of Tesla to achieve, what was it? Being awesome?
Is the most innovative. What is the most innovative company in the world? What's the secret of Tesla to do?
I mean, I don't know if there's a single secret here. It really, it doesn't usually work that way. People always want to know, like, what's the one big innovation or what's the one single thing. But, in reality, innovation and entrepreneurship is 1,000 little things. It's working really, really hard, solving a whole series of smaller problems, to get to an end goal that ends up being a lot bigger. So, I think just some of the things I've mentioned are probably part of what helps us succeed more than we fail, but we don't succeed all the time. That's pretty key. I think, people often see success and then they kind of maybe don't notice the failure as much. But you definitely have to be willing to fail in order to do anything meaningful. And, maybe we're more willing to fail than a lot of other companies, and I think, more willing to take, big risks when we know the end outcome is meaningful and important. So perhaps something like that. Okay, over here.
Hello. Well, I actually have two questions. First question is in the sense of, you talk about the batteries are made of lithium and all this stuff. So, but all batteries have some period of life, right? So, what is the company doing in terms of recycling or utilizing these batteries after some, I don't know how many years, right? That's the first question. And the second question is in terms of private transportation. I think it's a good idea to have cars, but what about any idea to have motorcycles, electric motorcycles? I don't know if there is any direction to build to work with us on that direction.
Good questions. As I hinted to before, recycling is really important to us. We have a whole team internally that's working on recycling. And, our vision is essentially to take back batteries from the field and eventually, reprocess those into the same raw materials that we can use to make new batteries. That is technically possible. There's no reason we can't do it. So that is really the goal that we have on how we want to do recycling, and we want to do it ourselves. There's a lot of companies out there today that recycle different things, but no one is really excellent at recycling batteries yet. And we see that as a great opportunity to both help the environmental footprint at the end of the battery's life, but also to reduce cost. Because as I mentioned also, when we can recycle a battery, we get back the materials much cheaper than we do if we have to mine them from the earth anew. So it saves money and it helps the environment. So recycling is great. The only thing is that the batteries last kind of a long time. They might last 15 years. So it takes a while, for us to have enough products that are actually needing to be recycled, to have a kind of a full ecosystem running. Even today, we don't see really any of our cars coming back. Even the first roadsters are still in service and the batteries are still working fine. So we have to wait a few more years before, things start coming back from the field, but we're working on the technology now. And the second question, motorcycles, I think it's a great solution. There's a ton of startup companies, ton of new companies working on motorcycles. I have a few friends of mine in California that have already started motorcycle companies, and they're growing those. In Asia, electric motorcycles and scooters and electric bicycles, it's a massive market, millions and millions of them being sold. So, that's a really competitive market, and it's very exciting, and I think it's going to do some amazing things. So I'm fully in support of it. It's just we have to focus, and we can only do so many things at a time. So, thank you.
The last, la última, por favor.
Hi.
Muy bien. Me parece genial lo que está haciendo Tesla Motors. Ahorita Tesla Motors trabaja en vehículos. Mi pregunta es lo siguiente. Creo yo que va a ir evolucionando y va entrando en otros temas como las baterías de litio para móviles o para uso en casa habitación. Y veía yo que las reservas mundiales de litio, el 85% de las reservas mundiales solamente está en 5 o 6 países. Bolivia, China, Chile, creo que no recuerdo más dónde vi, pero 5 o 6 países. ¿Cómo va a lidiar Tesla Motors con las políticas públicas o las políticas de economía de estos países, porque sabemos que ahorita pues muchas políticas se basan en el petróleo, en lo que viene siendo la energía fósil. Entonces, ¿cómo le hará Tesla en este caso?
Not sure if I understood all of that, but I can try and. I think the question was about when and how will we expand into regions that have very cheap oil or cheap fuel. Is that close?
We can. The question pertains more to towards the reserves of lithium and regarding and pertaining to the capacity to actually produce batteries. He's talking regarding the concentration of lithium is currently in 5 or 6 countries. So
okay.
how is Tesla going to deal with the actual political climate of those 6 countries or 7 countries or regions in order to be able to produce efficiently and meet the demand side? No?
Yeah. Okay. Well, today that's where most of lithium comes from, or those 5 or 6 countries in South America. But that's not the only place it exists. And we see a huge, rush of other companies, going into different markets. Australia, has new resources and new mines coming online. China has a few big mines. There's some in the U.S., actually, in Nevada. Mexico even has some in northern Mexico. Canada. So people are finding lithium all over the place. It's just the very, sort of simple, easy lithium in the sort of, salars and the dry lake beds in South America is where people went to first. But I don't think that's going to be where most of it ends up coming from. In fact, actually, lithium, is present even in seawater. There's a lot of different salts and minerals dissolved in seawater. And lithium, if you kind of go and look at the composition of seawater, is one of the top, concentrated elements in seawater. And today it's still too expensive to extract it from seawater. It's much cheaper to go to South America. But it will put a floor, or I should say a ceiling, on the price that lithium could ever be at. Because eventually, if the price rises enough, people can actually extract it from seawater. And essentially that becomes almost an unlimited resource, but at a higher price. So I don't see lithium being a big problem for batteries. It's only a few percent of the battery cost today. A lithium-ion battery is, again, made up mostly of nickel and copper and graphite, a little bit of cobalt. There's only a small amount of lithium. It's kind of like the secret ingredient, the salt that adds the flavor to it. But it's not the majority of what makes up the battery. So the prices could rise, they could change, and they won't affect the end strategic outcome of the whole, of the whole mission. But good question. Thank you.
Muchas gracias.
Thank you very much. Appreciate your time.
Thank you, JB. Thank you for being here. Muchas gracias.
Thank you.
Bueno, muchas gracias a ustedes también por estar con nosotros. Muchas gracias. Y que, bueno, este inicio de jornada, thank you, JB, sea muy venturoso. Tenemos 3 conferencias magistrales más en lo que resta del día. La siguiente dará inicio exactamente a las 2 de la tarde con la presencia de Gustavo Gutiérrez. Será también algo muy, muy interesante. Los invitamos a aprovechar cada rincón, cada espacio de esta semana del Emprendedor 2016. Nos vemos a las 2 de la tarde. Muchas gracias.